Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we discussed about Bellman-Ford algorithm and Dijkstra's algorithm. In this session, we will learn Floyd Warshall algorithm. Overview of the session. In this presentation, so first we see introduction to Floyd Warshall algorithm. After that, we discuss this algorithm with one example. After example, we see what is the algorithm, Floyd Warshall algorithm, and finally we discuss about time and space complexity of this algorithm. Outcome of this lecture: at the end of this lecture, you all are apply Floyd Warshall algorithm to find shortest path between all nodes in a graph. So, introduction to Floyd Warshall algorithm. The Floyd Warshall algorithm used to find shortest paths between all pairs of nodes in a weighted graph. So, this algorithm is highly efficient and can handle graphs with both positive and negative edge weights. In our previous two classes, we discussed about two algorithms. One is Dijkstra's algorithm, another one is Bellman-Ford algorithm. In these two algorithms, we discussed how to find shortest path from one node to remaining n minus 1 nodes in the graph. In Floyd Warshall algorithm, we are going to find shortest path between all the nodes present in the graph. So, let us discuss with one example. So, these are the, let us consider this graph. So, these are the weights. Now, Dijkstra's algorithm, Bellman-Ford algorithm, these two we are going to use to find shortest path from one node to remaining all the nodes. So, for example, if I select A as a source, now we find the shortest path for A to B, A to C and A to D. In Floyd Warshall algorithm, we are going to find shortest path between all pairs of the nodes. For example, here we are going to find the shortest path from A to B, A to C, A to D, and after that again you can select B, and for B we are going to find the distance B to A, B to C, B to D. Similarly, for C we are going to find C to A, C to B and C to D. For D we are going to find D to A, D to B and D to C. So, this is Floyd Warshall algorithm. So, what is Floyd Warshall algorithm? So, this algorithm is used to find shortest path between all pairs of nodes in a weighted graph. So, let us discuss with one example. So, let us consider this graph. So, for this graph, first we are going to find matrix. So, n by n matrix. Now, that I consider as a D naught. Okay. Now, what is the size of the D naught? That is based on number of vertices. Here the vertices are 4. So, 4 into 4, A, B, C, D. A, B, C, D. Okay. So, this is the D naught. Now, we fill the matrix. So, A to A distance is 0, B to B 0, C to C 0, D to D 0. Now, find there is an edge between A to B with cost 8. So, you write 8 here. Now, A to C there is no edge here. So, write as a infinity. A to D, yes, there is a edge with weight 1. So, B to A, there is no edge. So, infinity. Now, so B to C there is a edge with weight 1. So, B to D infinity. Why? There is no edge. Similarly, C to A there is a edge with cost 4. C to B no edge infinity. C to D no edge infinity. So, D to A there is no edge infinity. So D to B, it is 2, cost is 2, and D to C cost is 9. So this is the initial matrix. Okay. So now we are going to find the distance of all these vertices using an intermediate node. So for example, here if I want to reach A to B, now so A to B, there is an edge. What is the cost here? 8. But maybe there is another path from A to C and C to B, or there is another path from A to D and D to B. So in these paths we are going to find shortest path. So in this algorithm we are going to consider intermediate vertex. Now to reach from A to B, we are going to check A to C and C to B, and next iteration we are going to check A to D and D to B, and we check A to B also. Now in these values we are going to take the minimum value. Okay. So let us see here. The formula is, for example, I want to reach U to V via some vertex. If D of U comma V is greater than distance of U comma via vertex plus distance of via vertex comma V. If it is true, then distance of U comma V equals to distance of U comma via vertex plus D of via vertex comma V. So what it is? For example, if I try to find the distance between A comma D via B. Okay. How we find distance of U comma V? Distance of A comma D greater than distance of A, what is the via vertex? B, plus distance of B comma D. If it is true, then we are going to assign distance of A comma D equals to distance of A comma B plus distance of B comma D. Okay. Here if you observe A to B, what is the actual value of A to B? The distance is 8. If you traverse A to B via D, then the distance will be 3 now. Now here if you traverse from distance of A to B via D, now distance of A to B is 8 greater than, so what is the distance of AD? 1 plus what is the distance of DB? 2. 1 plus 2, 3. 8 greater than 3. Now we make the distance of A comma B as a 3. Okay. So this is the simple formula. You remember this formula? The same formula we are going to apply for all the vertices in the graph. Okay. So now we find the distance of all the vertices by using the via vertex as a so that we call as a D1. Okay. To fill this A1, the input is D naught here. Okay. So same entries A, B, C, D, A, B, C, D. Here the via vertex is A. So all the entries belongs to A, we fill with the previous values only. Why? So A to A we reach, the via vertex is also A. So here A entries are, so these two lines. So this is the A entry and this is the U entry. So both the horizontal and vertical entries belongs to A. We write as it is 0, 8, infinity 1, here infinity 4, infinity, and the diagonal are all zeros. That's it. Now we are going to find the remaining values. Okay. Now first we find distance of B to C. Via vertex is A. Now what is the formula? So distance of B to C means distance of B to A plus distance of A to C. Okay. So what is the actual value of distance of B to C? That is 1. So we are going to compare the result with 1 here. So what is distance of B to A? B to A distance is infinity plus, so distance of A to C is infinity, that equals to infinity. Now compare, 1 greater than infinity, false. So I write same value here. What is the value? 1. So 1 I write here. Okay, next, distance of B to D. So what is the formula? So distance of B to A plus distance of A to D. That's it. Now pause the video and you find the distance of B to D. Now what is the actual value of distance of B to D? B to D actual value is infinity. So distance of B to A is infinity plus, so distance of A to D is 1. That means 1 plus infinity. Now infinity greater than 1 plus infinity, false. So again we write the same value here. What is the value of BD? Infinity. I write infinity here. Okay. Next, this entry, distance of CB via vertex A. So distance of CA plus distance of AB. So what is the distance? What is the actual value of distance of CB? CB is infinity. Now distance of CA is 4. Distance of AB is 8. 4 plus 8, 12. So now check, infinity is greater than 12. Yes, it is true. So now you assign 12 to distance of C to B here. Now here you write 12. Okay. So next one, distance of C to D. What is the formula? Distance of C to A plus distance of A to D. So what is the distance of C to A? 4 plus, what is the distance of A to D? A to D is 1. So 4 plus 1, 5. So what is the actual of distance of C to D? Infinity. Infinity greater than 5? Yes, it is true. So now I assign 5 as a distance of C D. So here it is 5. Okay, next entry, distance of D to B. So distance of D to B means distance of D to A, via vertex is A, distance of A to B. Okay, so what is distance of D to A? D to A is, so what is the actual value of distance of D to B? 2. Okay, I write here 2. Now distance of D to A is infinity plus distance of A to B is 8. So 2 greater than infinity plus 8, false. So I store same value 2 here. So next entry, distance of D comma C. Distance of D comma A plus distance of A comma C. So what is the actual value of distance of D comma C? 9. 9 greater than distance of D comma A means D comma A is infinity plus distance of A comma C is infinity. So this is false. So I write same value 9. That's it. Okay. Now so first iteration is over. Here we consider A as a y vertex. Now we are going to apply same algorithm by changing the intermediate nodes. Here I take A as a intermediate value. In next iteration I am going to take B as a intermediate value and this matrix as a input. Okay. So I write D2 here. D2 equals to A, B, C, D. Same A, B, C, D. What is the y vertex? Via B. So all the values belongs to B we write as it is. Okay, these values. So infinity, 0, 1, infinity. So vertical 8, 0, 12, 2 and diagonal values are all zeros. Now we find the remaining values. What are the remaining values? Distance of A to C, distance of A to D, so distance of C to A, distance of C to D, so distance of D to A, So distance of D to C. So these values we are going to find. So what is the y vertex? B. So distance of A to B plus distance of B to C. Here distance of A to B plus distance of A to D. Here distance of C to B plus distance of B to D. Here distance of C to B plus distance of B to D. Here distance of D to B plus distance of B to A. Here distance of D to B plus distance of C to A. That's it. So now what is the actual value of distance of A to C? A to C is actual value is infinity. Now what is the distance of A to B? A to B distance is 8. 8 plus distance of B to C is 1. So 8 plus 1 9. Infinity is greater than 9. So it is true. So here I write A to C distance as a 9. Okay. Next find A to D. So A to B distance is 8. So this is B to D. So distance of A to B is 8 plus distance of B to D. B to D is infinity. So what is the actual value of A to D? 1. 1 greater than 8 plus infinity? False. So here I write the same value, that is 1. Next, so distance of C to A. What is the distance of C to A? 4. The actual value is 4. So distance of C to B. C to B is 12 plus distance of B to A. So distance of B to A. So distance of B to A is infinity. So now what is actual value? 4. 4 greater than 12 plus infinity? False. So I write same value here, 4. Next, distance of C to D via B. Distance of C to B is 12 plus distance of B to D. B to D is infinity. Now what is actual value of distance of C to D? 5. So 5 greater than 12 plus infinity? False. Okay, so I write the same value, 5 here. Next, distance of D to A. What is the actual value? Infinity. So distance of D to B. D to B is 2. Distance of B to A? Infinity. So infinity greater than 2 plus infinity? False. So write same value, infinity. So next, so distance of D to C. What is the actual value distance of D to C? 9. 9. So distance of D to B is 2 plus, so distance of B to C is 1. So 2 plus 1, 3. So 9 greater than 3, yes, it is true. So now 9 is replaced with 3 now. That's it. Now this is the D2. So now we are going to find D3. Here y vertex is C. So these are the entries A, B, C, D. So for this D3 the input is D2. Here y vertex is C. So first write all the entries of C. So these two vertical. So this is the horizontal. So these two values we are going to write 4, 12, 0, 5. For C 9, 1, 0, 3. So diagonal values are 0. So now we are going to find the distance of A to B. So distance of A to D. So distance of B to A. So distance of B to D. So distance of D to A. Distance of D to B. Intermediate vertex is C now. So distance of A to C plus distance of C to B. So distance of A to C plus distance of C to D. So distance of B to C plus distance of C to A. So distance of B to C plus distance of C to D. So distance of D to C plus distance of C to A. So distance of D to C plus distance of C to B now. Okay. So now what is the distance of A to B? A to B distance is 8. Now what is the distance of A to C? A to C is 9 plus distance of C to B is 12. So 9 plus 12, 21. 8 greater than 21, false. So we write same value, 8 here. What is the actual value of distance of A to D? 1. Find distance of A to C is 9 plus distance of C to D is 5. So 9 plus 5, 14. So 1 greater than 14, false. So I write same value, 1 here. Next, distance of B to A. B to A is infinity. Actual value is infinity. Now find distance of B to C. B to C is 1. So distance of C to A is 4. So 1 plus 4, 5. So infinity greater than 5. So now this is true. So I write 5. So next, distance of B to D is actual value infinity. So distance of B to C is 0. So B to C is 1. So distance of C to D 5. 1 plus 5, 6. Infinity greater than 6, yes, it is true. So I consider the distance of B to D as 6. So next one, so distance of D to A is actual value is infinity. So distance of D to C is 3. So distance of C to A is 4. 3 plus 4, 7. Infinity greater than 7, true. So I write 7 here. Next, distance of D to B. D to B actual value is 2. So distance of D to C is 3. Distance of C to B is 12. 15. So 12 greater than 15, false. So write, so same entry 2 here. That's it. Now we are going to find D4. In this D4, the via vertex is D. The input is D3. So all the entries belongs to D. We write first 7, 2, 3, 0. Vertical 1, 6, 5. Diagonal values are zeros. Okay. So now we are going to find the remaining entries. So what we are going to find? The distance of A to B via D here. Another distance is A to C. So another distance is B to A. Another one, distance of B to C. Another one, distance of C to A. Another one is distance of C to B. That's it. Here the intermediate vertex is D. So distance of AB. How we find distance of A to D plus distance of D to B. Here distance of A to D plus distance of D to C. So distance of B to D plus distance of D to A. So distance of B to D plus distance of D to C. So distance of C to D plus distance of D to A. So distance of C to D plus distance of D to B. That's it. Okay. Now what is the actual distance of A to B? A to B distance is actual value 8. Now we find, so distance of A to D is 1 plus, so distance of D to B is 2. So 1 plus 2, 3. 8 greater than 3, true. So replace 8 with 3 now. Okay. So next, A to C. What is the distance? 1. A to D distance is 1 plus distance of D to C. D to C is 3. 1 plus 3, 4. So what is the actual value of A to C? 9. 9 greater than 4, 2. So I consider 4 as a distance. Okay, next one, B to A. What is the actual value of B to A? 5. Now distance of B to D. B to D is 6 plus, so distance of D to A is 7, that is 13. So 5 greater than 13, false. So I consider 5 only. So next, so B to C, actual value is 1. Now you find distance of B to D is 6 plus distance of D to C 3. 9. 1 greater than 9, false, so I consider 1. Next, so distance of C to A, what is the actual value? 4. So distance of C to D is is 5. So distance of D to A is 7, 12. So 4 greater than 12, false, so I consider 4. So distance of C to B, actual value is 12. So here distance of C to D is 5. So distance of D to B is 2. 5 plus 2, 7. So 12 greater than 7, true. So I consider 7 here. So that's it. Now, so this is the all pairs shortest path. Okay, from A to A 0, A to B 3, A to C 4, A to D 1. So B to A 5, B to B 0, B to C 1. So B to D 6. C to A 4, C to B 7, C to C 0, C to D 5. So D to A 7, D to B 2, D to C 3, D to D 0. Okay, so this is the solution for this graph. So now we see algorithm. So what is the first step? Initialize the solution matrix same as the input graph matrix as a first step. Okay, so first initially we are taking n by n matrix. In that we are going to store all the cost values. Then update the solution matrix by considering all vertices as an intermediate vertex. In our example, in first iteration I consider A as a intermediate vertex, in second iteration B, in third iteration C, in fourth iteration D. So then the idea is to pick all the vertices one by one and update all shortest paths which include the picked vertex as an intermediate vertex in the shortest path. So when we pick vertex number k as an intermediate vertex, we already have considered vertices 0, 1, 2 up to k minus 1 as a intermediate vertices. What it means? If there are k vertices, first we are going to consider 1 as a intermediate vertex, in second iteration 2, in third iteration 3. Okay, except k, we are going to take all the remaining vertices. For every pair I comma j of the source and destination vertices respectively, there are two possible cases. K is not an intermediate vertex in shortest path from I to j. We keep the value of distance of I comma j as it is. So what it means? If there is no edge between those nodes, then we are going to write infinity, or if there is no path, then we are going to take the previous value only. Okay, so next, k is an intermediate vertex in shortest path from I to j. We update the value of distance of I comma j as distance of ik plus distance of kj if distance of ij is greater than distance of ik plus distance of kj. I hope you all are understand this algorithm based on what we discuss in this example. Okay, so this is the algorithm. Here n is number of vertices. We are taking one matrix with the size n into n. Here we have three loops. One is k, intermediate node, and I, j. Okay, now we are going to find the minimum shortest path and we assign, considering k as a intermediate node, and we return the matrix. Okay, so time and space complexity. Here we have three loops. There are three loops. Each loop has constant complexities. Here the each loop we run up to n. So the time complexity of Floyd Warshall algorithm is big O of n3, and here we are taking a matrix with the size n into n. So the time complexity of the Floyd Warshall algorithm is big O of n square. So coming to summary of this algorithm, Floyd Warshall algorithm. So the Floyd Warshall algorithm addresses the all pairs shortest path problem, which involves finding the shortest paths between all pairs of vertices in a weighted graph. So we have three steps. One is setting up the initial distance matrix, iteratively updating the distance matrix to compute shortest paths, updating distances based on intermediate vertices. So what it is, for example, if I found distance of A to D via B. Now what is the formula? So distance of A to D is greater than distance of A to B plus distance of B to D. If it is true, then I am going to assign distance of A to D equals to distance of A to B plus distance of B to D. I hope you all are understand Floyd Warshall algorithm. If you have any doubts, so ask your questions in comment section. I will answer all your questions. Thank you.